Back at it with 11.2. I said today we were moving on to dependent events, which is the plan. I just want to stop and pause and review that independent events were with replacement. So knowing that little bit of review that independent was with replacement, that's going to mean dependent means without replacement. And it's done by this formula. So the probability of A and B happening is going to be the probability of A times the probability of B given A has already happened. I like to use this little line I put down here without, because for me, it's like taking A outside of B. So in this case, we are going to figure out what we do after we've already taken A out. Okay. Suppose 12 candies are hidden in a bag. Okay, we've got 7 red, 3 blue, 2 yellow. What is the probability of selecting 2 consecutive blue candies without replacement? Okay, so we're gonna have a blue and then we're gonna have a blue. I'm gonna write this a little bit different today. So this is gonna be our first blue and this is gonna be our second blue because they want 2 back to back. So our first blue is just a normal probability. I have 3 blue out of my 12 candies. So that's going to be 3 over 12. However, by the time I get around to taking out my second blue, I've only got 2 blues left and I only have 11 candies left. So that becomes 2 out of 11 because remember, this is without replacement, so I'm not putting that first blue back. Unlike yesterday where I was putting them back. I'm not doing that today. So when we multiply this, we're not going to get something where the bottoms are the same. So, well, they're not going to multiply to be the same as they would have yesterday. So 3 times 2 is 6 over 12 times 11 is 132. Okay, and we can simplify that by dividing the top and the bottom by 2, which is going to give me 3 over 66, which can still be divided. Divide by 3. Divide by 3, and we're going to get 1 over 11 as our final answer. You can put that into decimal form for sure. In fact, that's probably going to be the easiest way to do that. So I'm going to put or decimal because I will probably ask for decimal on your work coming up, but I will give the option to put the fraction as well. So just to keep in mind, this is without replacement. So what I did was I took the blue out here. I had a 3/12 of a chance of taking that out. So I succeeded. I took out the blue here. So now I am left over with just the 11 candies because I took one of them out and it wants another blue, which means I'm still down to the 2. So for this one, I end up just subtracting across the top. So what's going to happen if example D has the question? So suppose 20 candies are hidden in a bag. 9 are red, 3 are blue, 8 are yellow. What is the probability of selecting a blue candy and then a red candy without replacement? So one of the things with dependent events is that order matters. In example C, it didn't really matter which one I did first because they were both blue. However, this is specifically stating I take out a blue, then I take out a red. So my first event is a blue comes out. My second event is that a red one comes out, okay? So I'm gonna find the probability of my first one happening because remember, it comes first, so this one's gonna be the easier one. Okay, I've got 3 blues and I've got 20 candies. Okay, so that blue is gone. I'm down to 2 blues and I'm down to 19 candies. I removed it. Now, my next probability is asking that a red is removed. So I've got 9 reds and I have 19 candies left because remember I took out my blue. So I'm going to multiply. I'm going to end up with 27 over 380, or again the decimal version of that. So the main thing that we are paying attention to here is 2 things. Wording, meaning if it has with or without. And then order. What comes first? Okay, so if any of these other examples had have said I do the red first, then the blue for the second example that we did, that would change everything about the formula, everything about the order of which we multiplied, everything about the fractions. Okay, you have to pay attention to order. You have to do the first things first. A lot of times in math you can say, oh, I'm going to plug in 2 for x. I can do that for the first equation or the second equation, doesn't really matter. It's going to end up being the same thing. Not for these. Order matters. You also have to pay attention to if it is saying with or without. These are independent events, these are dependent events. Okay, so with or without replacement, independent versus dependent, and for the dependent events, what comes first? You have to pay attention to order. Okay.